Okay, I'm testing this. All right. I am going to take us past week 7 and into week 8. This is the meat of the course. I'm going to do a very simple problem, and just to set the information up. So let's go to the book and let's see where I am in this. Oops, that's chapter 12. Give me a minute. It'll take me a minute to find this now. Okay. Thinking it's 17, but I may be wrong. Yeah, but let's get down past this. Okay, no, no. We may need to go back to 16. Kinematics. Okay, so in the lectures, all of this is covered. So you can go look at all that in the lectures, and you get your way through. This material up to and around. Well, give it a second. Okay. This is where you start seeing the interesting difference between a lot of this. So here's the relative position equation, and imagine you had this rod and A and B have a fixed distance between them. In other words, A does not move away from B or move towards B because it's on the same link. So this gives you the fact that the motion of B relative to A is all about its own rotation. In other words, if you are at A and you look down to B and then you look at it again, what you've noticed is it's rotated about you. It's rotated that way. You don't notice anything else. So if you have the equation of motion or some information about the translation of A and the rotation of the link, then you can determine the information about what's happened to point B, the other point on the link. The implications are when you go to the velocity, you will find something very interesting, and you get down to about right here, and this is what you find out. Again, this is only because of the rotation. Now, as it turns out, this is similar to what you've seen before. The difference being that the points A and B don't change their distance from each other. So let's go look at a particular case and just set it up and just go with it there. And here we go. So let's say we have a link. This thing is out here, and this is point A, this is point B. I'm going to make this 3. I'm going to make that 4. I'm going to make this go down to a link right here, which again, that's going to be 4. And this one I'll say is 6. So let's say this thing is rotating with omega equaling to, let's just say 1 radian per second. So now, here's the difference, okay? We're going to keep ourselves in an x, y coordinate system. We're going to stay Cartesian even though we have rotation. Oh, I need to call this C. So, and we'll say it's on wheels. It goes back and forth across this as this link goes backwards and forwards. So, we could write the velocity of B is equal to the velocity of, well, B relative to A plus velocity of A. If this is fixed to the ground, then it has no velocity. Then what you realize is this is the omega of link AB. So the equation that you saw a minute ago was omega cross. Okay. So this was omega AB cross R B to A. So here's the key. The subscripts here, same as the subscripts here and here, but they usually don't write, they write this as AB, the omega of the link AB. So what is RAB? I mean, what is this term? Well, if you just look at it, pretty simple to figure out. It's a vector that goes here. So R B relative to A is nothing more than 3I plus 4J. That's it. What is omega AB? Now here's where the right hand rule is. Take your right hand, the thumb, as you take your fingers and rotate around this direction, your thumb points up. That makes it, if in a vector form, omega AB is equal to 1K. So what do you get? You get 1K crossed with 3I plus 4J. Now, the other way you can do it, and this is what I like to do, list the first row as this one, and the second one here. And so it'll get 0, 0, 1, 3, 4, 0. And then you can do a cofactor expansion. Take this one, put here, minus j. If you're taking a j, you take this and this, put there, 0, 3, 1, 0. And then plus k, and eliminating that row and that column, you get 0, 0, 3, 4. So in this minus that gives you minus 4i. This minus that, but that's a minus over there, plus 3j. This would be the velocity of B. Now, does that make physical sense? If you zoom in on it and maybe move some of the items away, and then just say this is omega AB, then the vector itself is going to be going in this direction. We'll have a positive y component and a negative x component. And that is what we get here. Now, the next step is running down the link. This occurs, this whole equation occurred because you were on one link and moving to the other. Hang on, I lost my phone. Oh, there it is. I was going to check the stream and make sure everything is healthy on the stream. Let me check. And then I'll wrap up the last phase of this. Let me check. Okay, it's working. And then I'll wrap up the last phase of this. Okay. Let me do the last bit. Okay. Now that I've got this, shoot. Move it over to the side. Come back in here, but this time when I come back, I'm going to say VB. I'm just copying this. Now, here's the next key. I'm moving down a link. Okay, velocity of C is equal to velocity of C relative to B plus velocity of B. Okay, B and C are on the same link. Over here, A and B are on the same link. You cannot do this. Velocity A relative C plus velocity of C. This will not work. A and C are not on the same link. So you have to exist on the same link. It just so happens that when you have linkages, B exists on both of these. So B up here exists on both links. So now what do you do next? Well, the velocity of C, I know it is either going to move to the right or to the left. I'm just going to assume it's to the right, and I'm going to just come up with the value, and I don't know what it is. Now this one, omega BC, is rotating somehow. I don't know how, but we will figure this out. R, C relative to B, and then the velocity of B. This can simply be copied right here, and this I, J, K will simply be written. I don't know what omega BC is, but it's coming out of the plane, RC to B. Okay, now this is a vector that originates at B, ends up at C, so it goes this direction. B 6 minus 4, 0. In other words, R drawn to C relative to B is a vector that goes to the right 6, and it goes down 4. So there you have it. What do you have? You have, let's do a cofactor expansion, write this out. I 0 omega BC minus 4 0 minus J 0 omega BC 6 0 K 0 0 6 minus 4, and then minus 4I plus 3J. This one gives you nothing. The final equation gives you this. I plus, and then minus that, but it's a minus already. Here. 4 omega BC I plus minus, then a minus, plus 6 omega BC J minus 4I plus 3J. What I'll do now, I'll highlight components of I, then I'll highlight the components of J. Just from that, you'll see the I components will give you one equation. Oops. And the J components get you the other equation. So, looks to me like right off, that has to be minus a half. And then if you put that, if you put minus a half in there, then you'll get that. You put minus a half in here, that would be minus 2 minus 4, or velocity is 6, C is equal minus 6. Meaning, let's take a look at it. Remember, okay, this is something I do often. If this is X and this is Y, this is a positive omega, positive rotation. And it turns out that in fact, if you were sitting on this link staring at C, C would be going to the left while this is going up. So it would be rotating in a negative direction. So I did that fairly quickly, but I'm going to basically call that the lecture. And this will give you an opportunity. You can go rewind and look at this. This covers most everything with respect to the velocities. And there are plenty of worked examples out there in this. And so we're just going to go with it like that.